against the Big Bang theory. And this point was made by one very popular person who was not considered a great scientist, a great physicist, but actually he was maybe one of the greatest of them. And it was Charles Darwin and his theory of evolution. So he has discovered that the so-called natural selection takes place in the biological world. That is, the species which have conditions and parameters and properties that allow them to survive, that is, they remain stable under these circumstances and conditions, they continue to exist, while all the others, they die out, they become the material for and food for other species. But Darwin, working in the sphere, in the domain of biology, he did not understand that his law was much more global than only biological law of biological life. Because of biological evolution can be considered as the evolution of organic molecules. But before the biological evolution started, another more wider and deeper evolution has taken place, and it was chemical evolution. Because of before biological species was able to begin to evolutionate, chemical evolution must have taken place, and it really happened. That is, on the surface of our Earth, that is, on our planet, we see what are the most popular chemical compounds. That is hydrogen to oxygen, H2O. This is silicium oxygen 2. That is, it's stones and sand and minerals, most of minerals and stuff like that. Then it's nitrogen 2. That is our air, 72% of our air. This is nitrogen 2. That is the only most stable compounds have survived and exist still, while all the unstable, they became nothing, and they became material for stable compounds. That is, in our on our Earth we cannot find any minerals or any natural compounds that explode very quickly, very easily, that are unstable and break into other compounds that begin their chemical decay. But this chemical evolution has taken, as we can observe, the planet SMO 313 in the constellation of Hydra, and the distance to it is 13 billion kilometers. That means that chemical evolution has started no early than 13 billion years before nowadays. But before chemical evolution, more wider and more basic evolution has taken place. This is nuclear evolution, and this evolution means that before the chemical evolution was able to start, only the stable and strong nuclei of atoms, the most nuclei of atoms, such as oxygen 16, such as silicium 28, such as nitrogen 14, such as hydrogen 2, they remained. Because of the protons and neutrons, they were repacking, and those nuclei of atoms that were not stable, we call them radioactive. They were decaying and splitting into other more stable isotopes, and only the stable isotopes of I atom they remained and they survived. That means that the nuclear evolution, but there is one point. One woman astronomer noticed it. I apologize that I don't remember her name. That our sun is a quite cold star, so it could not boil, it could not produce nothing heavier than helium. And that means that our star, the sun, just continues to burn something that has left after the proto-sun, the father of our sun, has burned to the end and bursted away. That is, there was also the father of our sun, so-called proto-sun, grandfather of our sun, proto-sun 2. And even if we assume that those those two stars, they lived only 5 billion years each, because of they were hotter and the process of evolution were taking place faster, faster in them. It means that the nuclear evolution was taking place approximately 15, no less than 15 billion years. But the protons and neutrons, they do not consist of they are not the smallest particles in our universe. That means that they are also compounds, and they consist of subnuclear particles. That means now they are called quarks, and these particles start to form protons and neutrons much more earlier. And approximately, as we see that every previous level of evolution takes more and more time, we must say that approximately 30 billion years required to create particles that became material for protons and neutrons. But they are also not the smallest one, and that means that their material, the so-called subnuclear evolution level 2, it was taking place, it was continuing at least 60, no less than 60 billion years, and this in sum says that our universe is at least no less than 90 billion years old. And this is this is possible to for us to see thanks to Charles Darwin. And Charles Darwin turned out to be more clever guy and more brilliant scientist than George Gamow, Alexander Friedman, Lemaitre and Hubble all together, who said that only our universe is only 5 billion years old. Indeed, it is 90 at least billion years old. And everything repeats in the history of humanity. And in the history of science, also the same process has taken place. Now look at Georges Cuvier. Georges Cuvier, he was a paleontologist in 1829, I think, yes. And he was studying and he was exploring our Earth and minerals. And he has made the theory, so-called catastrophism, that there were 27, also with his pupil Alcide d'Orbigny. With Alcide d'Orbigny, they stated that there were 27 catastrophes, 27 global disasters on the surface of our Earth, when all the previous world was erased or almost erased, and the big catastrophe was taking place, and it was changing all the face of our planet. But then a period comes Darwin, and Darwin proves that there were no great catastrophes, there were no so-called cataclysms, natural calamities, and stuff like that. And all the picture that they see, it was step by step, small changes, small everyday changes, evolution, small baby steps of evolution from day to day. And the length of time was considerably longer than they said. Darwin said that our Earth is at least 300 million years old. But now, also thanks to Darwin, we see that our universe is much older. It's at least 90 billion years old, thanks to him. And also Darwin has shown us that there are no Big Bang. Big Bang is the second reincarnation in the modern science of this theory of George Cuvier, catastrophism, that it was a catastrophe. There were no catastrophe. There is only a global, a universal evolution, and our universe actually is in the global, I would call it dynamical balance, and this balance was established many years before. The universe has always been and will always be in the state that we observe it now, because of globally there are only two processes in the universe: the process of transition of matter into energy, and the process of transition of energy into matter. And these two processes, they are already balanced by actually, and I'll explain it and show you this in the next video. Bye.